Okay, in this presentation, we had the opportunity to assist a customer who was working on this cluster out of 2004 Jaguar. I'm not sure what model of the Jaguar it was. And he was having issues in trying to acquire the data from the microcontrollers on which the design of this cluster is based. So I thought, we would give him some assistance, and he sent us the cluster. So given the fact that we have it, I thought it would be perhaps helpful to folks to see what we needed to do in order to read the information from this cluster. And it turned out to be significantly different than what we had expected. So let me just go over what we found when we took the back cover off of this module. Okay, now I've already done, so I didn't want to spend a lot of time basically showing things that we've shown in other videos. So I wanted to be sure that we would have the opportunity for success when we made the attempt to read this. So let me just show you what we have here. I've already attached this. This is another case of when you open a module, you never know what you're going to find. Sometimes it's as simple as a single EEPROM. Sometimes it's more complex, and this one turned out to be a bit more complex. So let me show you what we've got here. We have two Motorola microcontrollers. These Motorola microcontrollers, their part number is 68HC11KS8. Okay, and these are parts that are supported by our Automotive or Locksmith Kits 1 or Locksmith Kits 2, since it's the Motorola microcontroller family. And we have one microcontroller here, okay, and another microcontroller over here. And this one had a sticker on it, which I did not remove, which was not necessary in order to determine what these processors were, but they're both the same. Okay, so I'm going to zoom in so you can see how we determined what these processors were. Okay, if you look at the top of the chip, you'll see it's got the Motorola M with a circle around it. That's how you know it's a Motorola part. It does not have the part number. The other processor did have the part number, but the problem was when I peeled the sticker off, the part number kind of went with it. So it was very difficult to read it and get it in the just proper angle in the light in order to read it. So I'm going to show you how we know what this is. If you look at the second line there where it says 0H98X, okay, that's what's called a mask number. And in many other videos that I've done, we talk about mask numbers of Motorola processors. But in this case, I want you to understand how it is that we know the actual industry standard part number that we're going to use to select this component. So let me grab my cross-reference sheet and I'll show you. Okay, here's the cross-reference sheet, which allows you to cross-reference the mask number to the actual industry standard part number. And if you look right here, it says H98X, and the industry standard number is 68HC11KS8. Okay, so that's how you know which part to choose. We also have the cross-reference list built into our software, but I didn't bring that up. So I'm just using the list, the hard copy list that we include when you reference or purchase the ACOM 2 or one of the Automotive or Locksmith Kit number 2. Okay, so that's how you know. And what we're going to do now is we're going to enter that part number so we can select the device. Okay, I've already got the software started, got the ACOM 2 installed in the programming unit, so I'm not going to go through all that, but we'll go down here and get to the Motorola microcontroller family, which is right here. And go over to 68HC11 KS8. As soon as I can find the 68HC11 KS8, KA2, KA4, KS8. Okay, so we're going to select it, we're going to press enter, that will choose the part. Here's what you see next, which is which adapter you need, how to set the switches on the programmer, and how to set the switches on the adapter. Okay, so that's how we prepare the system to read this part. Okay, the other thing that we need to do is when we read this part, we do everything in circuit. We don't make you unsolder parts if it's at all possible. Is to know we connect the ACOM2 with probes. Okay, probes on the appropriate pins, which are used to establish communication with the part. So how do you know which pins to attach the to which you attach the appropriate probes? Okay, well, let me show you that. Okay, this is the connection sheets. Actually, it's multiple sheets, which is included with the ACOM2 documentation. What we show are which pins on the processor that you need to attach the appropriate probe and the probe color. Okay, so the 11 family is one of the easier processors to attach, to which you can attach. But I do want to show you something here. Okay, pins 59 and 60 on this package are called mode pins. And what the mode pins do is they establish the operating mode of the processor when it comes out of reset. All right, and it's normal mode called single chip mode, which is the mode where it is running the program which allows it to be whatever it's controlling. Okay, in this case, it's the cluster, and I don't know which processor. It has two processors. I'm assuming one of them probably handles the display manipulation and updating of mileage and all of that, and the other one probably handles the security, meaning the immobilization function and that. I guess, I don't know, but it's got two processors. Whoever the designers were split the tasks up, where one processor does one thing and the other processor does something else. Anyway, the point that I wanted to make here is that the mode pins, in order for the thing to operate in single chip mode, one of the mode pins has to be at a logic 1 and the other mode pin has to be at a logic 0. And in order for us to communicate with the part, we need a different mode. We need a mode called bootstrap, which allows us to communicate with it. And in order to enter that mode, both mode pins have to be at logic 0. Okay, and when you attach the probes, we have two probes which will force those mode pins to be at a logic 0. Okay, well, that's all fine and dandy. And if another thing I wanted to point out here is this diagram is, it would apply to any of the K series part. We show it here where it says KA2, KA4. It would also be the KS family as well. The connections would align to the pins shown on this diagram. Anyway, so we'll hook up the probes in a minute to this part, but I wanted to explain to you about those mode pins because there can be a problem. And I'm going to move this this connection diagram because I'm holding it. And here's, we're looking back at the assembly. I did have the probes hooked up previously because I wanted to confirm that this was actually going to work. But as I said, the mode pins in this normal mode, one is at logic 1 and the other one's at a logic 0. And the one that's at a logic 1, good engineering practice suggests that the designer have his logic level assigned by pulling an input pin to a logic 1 level through a resistor. Okay? And most of the time in modules you'll see that they do that, but not this one. What they did in this one was they hooked the one of the mode pins, and I think it's pin 60 or 59, I don't remember. They hooked it right to the 5-volt rail, which is a positive power supply to the positive power source for the processor. Well, what happens is if you take and attach the probes as we indicate on the connection diagram, both of those probes will force both of the mode pins to a logic 0. Well, logic 0 is ground. And if the designer tied one of the mode pins to the positive supply rail and then we ground it, we short out the power supply, which does not hurt anything, but clearly it doesn't work. And one way that you can tell is that with the ECOM 2 has an LED on it, and the LED will go out as our power supply current limits and protects itself. So when that happens, what you need to do is identify which pin is causing the problem, and then you're going to have to lift it. There's no way around that. You can't have the mode pin tied to the positive rail and have the processor enter a communication mode. So what I'm going to show you is how we use another one of our products to make that determination prior to you hooking up the probes and shorting out the power supply. Okay, and the item that we use is our logic and test probe, and that is right here. Okay, the logic and test probe. I've shown this in one other video, but I'm going to show it in this video so that you can see it. Okay, the logic and test probe, its function is to, it has two functions. One, its function is to drive pins on, whatever you're trying to communicate with, to valid logic levels, and it uses the same circuitry as is used in our programming unit. So you'll know in advance whether or not you're going to be successful by where you've connected the probe. So that's one of its modes. It's called the test mode, and the other mode is called the probe mode. And the probe mode sets this to determine logic levels, meaning it's got an LED on it, and you'll see that work in a minute, which shows either a logic 1 or a logic 0. So you can determine, in some cases you won't need to attach a probe depending on what assembly you're working with. If the pin to which a logic level is required is already at the correct level, and this probe will allow you to determine that. So what I'm going to do is let me set this up, and I'm going to reattach the probes here, and I'll show you how the logic and test probe works, and then we'll go ahead and establish communication with the first processor. Okay, I've reconnected the probes to this part, so we should be able to establish communication. But before we do that, I wanted to show you how the logic and test probe connects. Okay, it has a black and a white wire which provide power to the probe itself, to the probe assembly itself. So it needs basically ground and a positive supply. And the way that we attach or acquire those voltages is here's the probe. You can see it's got the white and black wires. In the case of this processor, the gray probe is the positive supply, and you see these probes have two connection points, one on the top and one on the bottom. Okay, so right here is where we have the probe positive supply connected. It's right here on this wire. And then on the negative side, in order to supply the ground side, which is in this case the red probe, we have the black wire attached to the opposite side of that probe, so we can receive apply the proper voltage to the logic and test probe. Okay, so what I'm going to do now, I'm going to turn on the ECOM so you can see the logic and test probe start to work. Okay. Now, if you look at, you can see the LED is flashing because I'm in probe mode. Okay. And what will happen is if I touch the probe to a specific pin, as long as that LED continues to flash, I know that I'm able to drive the pin, and I won't need to lift that pin. Okay. If I switch the probe to probe mode, the LED turns yellow, and then it will turn red for a logic 1 or green for a logic 0. But we're going to use the test or the probe mode for our analysis now. Now, I've already determined that they didn't use good design practice with this particular assembly. So the processor to which I have the probes connected now, one of the mode pins was tied to the power rail. Okay, I determined that before I started doing this video, because encountering problems in the middle of doing a video isn't very professional, so we tried to avoid that. But anyway, since there's another processor, let me move down to that processor, and I have not done anything with that processor yet, but I'm going to assume that they probably didn't use good design practice on that particular processor either. So let me reposition my camera here so we can look at that. Okay, I've tried to position this so that you can see both the processor and the logic and test probe. Okay, you can see the LED blinking on the logic and test probe. So I'm going to touch the first pin of the mode pin, whatever it is, A or B, which is pin 60. And as I do that, assuming I can get it on here, you'll see that the LED turns green, which means it's 0. It's a logic 0. So I wouldn't actually need to put a probe on this if I didn't need to, okay? Because it's already at the proper logic level to communicate. Now let's move down to pin 59. Okay. Here we are on pin 59. Okay, and you'll see that the LED is now red, which means we cannot drive this pin. It's forced to a logic 1. Okay, so this pin is going to need to be lifted. Okay, or whatever. I'll show you what I'm going to do to quote unquote lift it, and then different people have different techniques, but this pin's got to come up in order for us to communicate with this part. So let me go and show you how to do that. Now, if I would have taken the logic and test probe and moved to all the other pins, transmit, receive, reset, and so forth, it would have continued to blink. Okay, so that's what would have been necessary in order to ensure that we could communicate with this part. Okay, so in this case, what I'm doing to lift this pin, I have some cutters, and I just put it at the there's a small flared area on the leg, and I put it right at that small flared area, and I clip that leg. Now I'm going to have to reconnect it with a small piece of solder after we do this, but that's how I lifted this pin. Okay, I've gone ahead and reattached the probes to the right-hand processor. I'm not going to basically read the left-hand processor because the procedures are the same. So I'm just going to show you how we're going to read the data out of the right-hand processor. Once the probes are connected and you turn on the ACOM2, the red LED on the ACOM2 will light. You'll also notice that I don't have the violet probe hooked up because on pin 60 it was already grounded, so I don't need to hook the violet probe up in this particular instance. Okay, once the probes are connected, we are ready to establish communication with the part. To do that, we're going to use our device options command, Command Z. So we're going to press Z, and we're going to choose option 1, which is upload 68HCXX communication program. So we're going to press 1, and we will see bootstrap upload in progress, buffer upload complete, communication verified. Okay, that means that the programmer is now communicating with the EEPROM memory in the part. Okay, so now all we need to do is read the data from the part. Okay, now that we're communicating with the part, we're going to go ahead and read the data from the EEPROM array into the buffer. We're going to do that. I'm going to use Command 3, which is read device into buffer. So I'm going to say Command 3, yes, and it will read. And there is the data from the EEPROM array. Okay, now that we have the data in the buffer, we're going to go ahead and save it. I'm going to use Command A to do that. I can use Command A from the buffer editor. And well, let's just see where we're pointing. Okay, let's use the directory command D, directory of files. We're in the bin files folder and bin files directory. I'll show you little secrets you can use here. I'm going to give this file the name jag1.bin. Okay, and this is called a recall file name, and it's a feature of our software which lets you assign a file name. You're looking at the files that are in the directory, and you want to give it a different name. You don't want to have to remember it, so you can just type it in and then press enter, and it'll be remembered. That's why we call it a recall file name. So at this point I can use Command A, and it'll sit down at the lower right hand corner. It says press insert to recall file name, so I'll just do that. I'll press insert, and there is the name that I saved. I'm going to press enter. Our software says save defined buffer range 0 to 27F, which is the size of the EEPROM array in the part, and I'm going to say yes. It'll say file save complete. Now let's see if it's there. So we'll press D for directory of files, and here we have right here jag1.bin. Okay, now if I wanted to, I could save that and or recall that data into the buffer if I chose to do so. I'll just show you how to do that. Okay, we'll go to Command 5 here. We'll clear this out, and we'll go back to the directory command, exit the buffer, directory command, jag1. And if you look down here in the lower right hand corner, it says file, F3 to program. I wanted to program it back into the part, or F4 to load. Well, I'm just going to load it into the buffer. Okay, so I'm just going to press F4, and it will load it into the buffer, and it gives you a summary, tells you where to place the data. And if I go back to the buffer editor, Command 5, there's the file. Okay, so anyway, there's a couple of things you can do. Pretty much wraps up this video. I'm not going to go any further with it, but anyway, this is how you would connect to and read a Motorola processor. In this case, it was a 68HC11KS8, and it also shows you how we use the Andromeda Research Logic and Test Probe to analyze if you determine whether or not you need to lift a pin. Okay, on a particular part. So that pretty much wraps up what I wanted to show you in this video. And that being the case, as I say in all of our videos, we appreciate the time you've invested in watching. If you like the content, you can give us a like. You can subscribe. Information about our products is available on our website, or you can call us if you would choose to do that, or you can send us an email. And our website is arlabs.com.